Happy Monday. We are halfway through the first module. It's been great to read everybody's reflections in their learning journal, as well as their posts and replies to other people's posts in the discussion board. As I had a chance to read through people's posts and replies, there's a few big ideas that I'd like to talk about that seem to cross many people's reflections. One big one is the idea of geometry being most problematic because it's not black and white like other areas of math, such as algebra. Teresa brought this up, talking about the gray area that exists in geometry. And Kate talked also about the variation that occurs because of the grayness of geometry. Courtney brought up the fact that geometry has a lot of rules, which should be black and white, but since the rules have exceptions, then you end up with a gray area that causes a lot of questioning and debate. Kate, building on this, remarked that some people love to argue and debate, some people don't. Some people like things to be very straightforward. And that is relevant to your class because you have some kids who probably like to argue and debate concepts, and others that seem to just want an answer, or at the very least, don't enjoy arguing ideas with other people. So, how do we balance what we're doing so that both of those types of kids are engaged? As we move on through this module, but also continue to read about other geometric concepts, a couple of questions to consider. One of them is, are particular areas of math indeed black and white or gray, as people seem to feel algebra and geometry are? Or is it just that they're taught in a way that suggests they are? And in regards to student preference, since many people mention the idea that some students just like to, find an answer and like things to be straightforward, is that preference for black and whiteness and straightforward math something that's inherent in some kids? Or is that a preference that is actually developed in them over time? And how does that develop? And I think that that has implications not just for geometry and for math, but for all learning. Another big idea was around proofs, and the general consensus was that proofs seem unnecessary, pointless, and pretty terrible. Vicky talked about remembering doing proofs, but not remember actually learning anything from them, and had the insight that when students are working on discovering, quote unquote, a thing that is given as true, then there's no real discovery happening, that they're just memorizing things. That was echoed by Ali Coleman, who, in thinking back on her own learning in geometry, recalls being taught all of this in a memorize and repeat way. Definitely not a discovery manner. One of the comments Jordan made about proofs that stood out to me was the idea of proofs adding unnecessary details and making math harder than it needs to be, which is a statement that even students in elementary school and their parents will often make when the idea of explaining one's thinking comes up. There are many students who are very good computers, and those students and sometimes their parents will often say they don't understand the point of being asked to explain how they know something is true, because they did it and it's right. And so the idea of explanation and proof being unnecessary and making math harder than it needs to be is definitely goes beyond the bounds of just geometry proofs. Allie Cummings brought up an interesting point about proofs, and that had to do with the idea that if proofs are built on givens, but students don't actually understand those things as given, then how can they actually make sense of what they're doing? And so I think a couple of questions that are worth considering going forward is, are the rules we tell students to take as givens really understood by them? And I think we can think outside of geometry, but to any area of mathematics. When we say to students that writing an equation with addends in a different order results in the same sum, or factors in a different order results in the same product, when they say that back to us, do they really understand that? Or do they just know that that is what they say? And finally, how can proofs and explanation, if we think of an elementary school and middle school corollary, how can they be a means to an end rather than the end in itself, which is what often they have ended up being? Finally, on one idea that had came up across many people's posts is the idea of misconceptions and how students can develop misconceptions when exploring with geometry and geometric concepts. Ashley brought this up and talked about the misconceptions that change as students are learning and the work that teachers have to do to correct them. And even talked about how being able to see past these misconceptions is part of students being able to own a given concept. When we think about misconceptions, it is important to recognize the difference between a misconception and a mistake. A misconception is a faulty belief, whereas a mistake is just an error. So a misconception might be an overgeneralization, but a mistake might just be made by leaving out a step or not understanding prior knowledge. Every misconception leads to mistakes, but not every mistake that a student makes is indeed a misconception. In geometry, if a student miscounted the number of vertices on a cube and ended up with 12, that would be a mistake. That's not necessarily a misconception about cubes. But if a student saw this figure and identified it as a square, and then when it was rotated said, well, it's not a square anymore, it's a rhombus, or saw this as a rhombus, but when rotated, so one of the sides is horizontal, said it's now a parallelogram, that indeed shows a misconception. That is a misconception about the way that orientation can affect what a shape is named. Tim brought up misconceptions across different subject areas and talked about one specific misconception students can develop with geometry, and that has to do with the idea of the area of a whole and how it relates to the area of its decomposed parts. So as you study more about the concepts that students might explore with in geometry from elementary school through middle school, I think it's definitely worthwhile to regularly be thinking, what misconceptions can students develop, but also how might we, through the materials we're giving them or the things that we're saying or how we're describing things, how might we be fostering misconceptions? This week we'll be wrapping up Module 1. The three main things that need to be addressed over the course of this week are the discussion forum, the learning journal, and the end of module project. So the discussion forum, by the end of this week, you'll just need to make sure that you've replied to at least one reply in each thread. You don't have to reply to every reply, and quite a few of you have already actually replied to a reply and met this criteria already, which is great. The learning journal, everybody did a first reflection, and you will just need to do a second reflection. In your concluding post, you can reflect on your learning by synthesizing, analyzing, reflecting on what you've learned and how you did it. Talk about how your thinking has evolved. Just please ensure that your learning journal entry is at least 250 words. And then finally, there's the end of module assignment. This is a task analysis paper. It is based around 2 illustrative mathematics tasks. It is to be 2 pages long. It's not designed to be lengthy. You are going to be looking at these tasks. You are going to be describing what the students are required to do, and then using what you've learned about the Van Healy levels to connect that learning to these 2 particular tasks. The bullets give you an idea of what you might describe in your paper, and you will need to have a references page with a minimum of 2 citations. Between everything that we've read, I think it'll be easy to be able to cite two things. As you are working on this paper, just know that this paper will serve as essentially an outline for the module assignment at the end of Module 2. So the work that you do here, you will be able to use all of it to make completing the Module 2 assignment a lot easier. The rubric for this assignment details what you need to do and how you'll earn the points for this end of module assignment. And just please make sure that you write the verification statement at the end of your paper so it can be accepted and scored. Best of luck this week, and please let me know if there's anything I can do to assist.